In this video, I'm going to discuss scalars and vectors. We'll talk about the differences and give some examples. So we've got scalars and vectors. The big difference is scalars are just magnitude. And magnitude, that means size of something. Well, size of something, or length of something, or amount. Okay, so for example, an earthquake that is magnitude 7 on the Richter scale. It tells you the size of the earthquake. Okay, a vector is also magnitude, but with a direction. So remember, in physics of motion in grade 10, to describe how something is moving, we need to know its magnitude, but we also need to know direction. If I say walk 5 meters, you don't know whether it's 5 meters this way, or that way, or that way, or that way. Right? We need a direction. So for example, if we say 10 meters, that's a scalar. If we say 10 meters north, that's a vector. So we can use north, south, east, or west for direction. We can also use positive and negative. So if we say positive 10 meters, that means 10 meters that way or 10 meters that way. Okay, up or to the right is positive usually. It is for Science 10 anyways. Okay, so distance. You know this word probably, distance, how far something has traveled. The symbol we use for distance is d. So for example, d equals 10 meters. Okay, there's no direction there, so distance is a scalar. You can never have negative distance. Displacement, on the other hand, is the change in position. Okay, so position, this is where an object is. And we use this symbol x. And we put a little arrow over the x to tell you that there is a direction. So if you see this arrow, it tells you that we're talking about a vector. Okay, so position is a vector. And displacement is the change in position. So the symbol for displacement is d, same as distance, but we put an arrow over it to show that it's a vector. And it's equal to the final position, f for final, maybe I'll write that in, final, minus the initial position, I for initial. Okay. Or we can write it delta x. This is the Greek symbol delta, and it means change. So change in position. And just one more thing. So sometimes you just see it written this way. xf minus xi. Final minus initial. Okay, now I know you know the word speed, right? Like the speed of a car, say kilometers per hour. So it's a unit for distance divided by a unit for time. So if an object, let's say a person walks 5 meters this way, and then they walk 3 meters this way, what is their distance traveled? Well, I think you can see it's 8 meters. Okay, let's say it takes 2 seconds to do this. So time is 2 seconds. So they went 8 meters in 2 seconds. Speed is v, and it is distance over time. So in this case, 8 meters over 2 seconds, the speed is 4 meters per second. But for the same object, let's describe the velocity. So velocity is a word that in everyday English, velocity and speed kind of mean the same thing. But in physics, there is a slight difference. Actually, it can be a big difference. The symbol for velocity is v, like speed, but it has an arrow over it to show that it's a vector. And it is equal to the change in position over the time. So if you look at this object, we went 5 meters one way and 3 meters back. So the final position is only 2 meters away from the start. And it's to the right of the start. So the velocity is positive 2 meters. That's the displacement over the time. Positive 1 meters per second. Remember, it has to have a positive or negative sign or something that indicates direction. So the velocity and the speed can be quite different. One more vector, which we'll study soon, is acceleration. I'll just put it in here for now, and we'll talk about it later. Acceleration is the change in velocity over time. So something that is speeding up or slowing down is accelerating. Well, maybe now would be a good time to stop the video and look back at the words that you've learned: distance, displacement. Okay, so review what is the difference between distance and displacement, what is the difference between speed and velocity. And in the next video, we'll walk through an example.